All right, yes, we have a mad gap. Another mad gap. Okay, again, we've got to learn the equation of a line. So we're going to review y equals mx plus b. Hopefully you know that m is your slope, or we call it the gradient as well. It could be called gradient because, like, if you're driving up a hill, they want to know what the gradient is so that your truck can make it up the hill or make it down the hill or whatever. So it could be called gradient or slope. And b, of course, is our y-intercept. Y-intercept. Now, on your graph, y is how far you go up, and x is how far you go along. Y is how far you go up, and x is how far you go along. M is your slope. You can just put slope. You might want to put next to it how steep the line is, though, because that is what we want to know for slope, how steep it is. And then y-intercept, you might want to write down where the line crosses the y-axis just to remind yourself. You probably know that already. You probably remember all this stuff. But our next task is going to be dealing with this stuff. The task that you're going to do tonight, that you're going to put into school net tonight, is going to be dealing with this material right here. So M is your slope, B is your y-intercept. Slope is how steep something is. You can also call it a gradient of how steep the grade is. And where the line crosses the y-axis is your y-intercept. And you can look at all the pictures on there. How do you find M and B? Well, B is easy. Just see where the line crosses the y-axis. So you look here, it's not on that picture, but you try to find where the line crosses the y-axis. That's your slope, or your B. M, the slope needs a little calculation. Okay, so your slope is the change in your y over the change in your x. How much the y changes over how much the x changes. Another way that we use it is we call it rise over run. So in this problem right here, your rise is 1, 2, 3. Your run is 1, 2, 3, 4, 5. And it's actually a negative 3 and a 5 because you're going down 3 and over 5. So this would have a negative 3/5 slope. It's the change in y over the change in x. Again, we call it rise over run. So you look at it, rise is how far you go up, run is how far you go along. So if I'm looking at this slope right here, you've got a rise of 3, and you've got a run of 1. So your slope would be rise over run, which in this case is going to be 3 over 1. Which equals 3. So if you see a 1 on the bottom, it's okay to leave it as a fraction. You don't have to. You can make it 3 instead of 3 over 1. Oh, you know what? You're right. We went from here. We went up 3 and over 5. So you're right. It is a positive. That is a positive 3/5. I counted backwards. So I thought it was going down. Good catch. 3/5 is correct. Okay, again, there's not a lot to fill in. I kept most of it there for you, so hopefully you're just able to fill in the blanks pretty quick. Here's example 1. Our slope here, you can probably see it, is going to be 2 over 1. It's going to be up 2 and over 1. So B is a 1, where the line crosses the y-axis. You could actually even make a point on your graph where the y-intercept is, so you kind of know that that's where it is. And so your equation would be 2x plus 1. 2 is your slope, and 1 is your y-intercept. So y equals 2x plus 1. Just in case you need to see it, there it is. Y equals 2x minus 1, or plus 1. That's how quick these are going to go. A lot of these are pretty fast. Hopefully you remember the slope and the y-intercept and all that stuff. I do want to just take a little bit of time to review it. That's why we're going over these. Okay, parallel line. That's where we are coming in, because that old stuff you should have down pretty good. But when we get to geometry, we've already been talking about parallel lines. right? When we talk about two lines parallel that are cut by a transversal, alternate interiors, alternate exteriors, all that kind of stuff. Okay, we have to also know on a graph, how can you tell if they're parallel? So again, algebra 1, but you hopefully remember what it was. Parallel lines have the same slope. That's the key thing for parallels. You just have to know they have the same slope. Equal slopes. That's the way you can test to see if they're parallel, is to see, do they have the same slope? Do they have the same M? So if I look at this bottom part here, it says find the equation of the line that is parallel to y equals 2x plus 1. You see the line 2x plus 1 right here? Parallel would be this line right here. It goes through the 0.54. It goes through that point. So what we would do is know that the slope of the line that we have is 2. The slope right here is a 2. So the parallel line must have the same slope to that. Now there's more to it on that slide, so that's just the first part. That's the first step, is to find the slope of your new line, which is going to be the same as the one that was the old line because they're parallel slopes. They're the same. So we already know that this is going to be a y equals 2x. We just don't know where this yellow line is going to cross way down here. Where is it going to cross the y-axis? That's what we got to figure out, because we need to find our b. But right now we have the slope is 2, and the parallel line must have the same slope to that 2. Now if you look at the next one, here it says, put that in the point slope equation. Anybody remember the point slope equation? That's our point slope equation. Y minus y1 equals 2 parentheses x minus x1. The 2 represents what? What is the 2? That's your slope, right? So this x1 and this y1 would be a point. So it's called the point and the slope formula, because you're putting in a slope and you're putting in a point. Now if you plug that in, if you plug in the 5 and the 4, it's going to look like this. The y1 was a 4, because that's your y value. The x1 was a 5, because that's your x value. So you just plug in the slope and you plug in the point. If you put those three things in, or those two things in, you can get it equal to y, and you'll have your equation. So my next step here was to put it in the slope-intercept form, y equals mx plus b. We want to take this and put it in the slope-intercept form. We want to take this equation, y minus 4 equals 2 times parentheses x minus 5, and we want to put it in y equals mx plus b form. What's the first thing we would do? First thing I would do is distribute here. So I'd get 2x minus 10, and I have y minus 4. Okay, so that's exactly what they did. They put y minus 4 equals 2x minus 10. And just one last step. What do we have to do? Just add 4 to both sides. So you're going to get the 4's to cancel. You get y equals 2x minus 6. So that's what it should be down here. Y equals 2x minus 6. It's parallel to 2x minus 1 because it has the same slope. Same slopes mean they're parallel. So if you look back at that picture, that yellow line would have crossed way down at the bottom at negative 6. That's where it would have crossed the y-axis. So parallel lines are going to have the same exact slope. Same slope, parallel, always. So you'll know if they're parallel by looking at the number in front of x, as long as you have y by itself. Okay, perpendicular. Perpendicular lines meet at a right angle, 90 degrees. We already know that. We've seen that. We wrote that down before. But now we need to know, how does their equations work? How do the equations of perpendicular lines? Anybody remember what their slopes are? They're not the same because that's parallel. Our perpendicular slopes. Inverses is half of it. What's the other half? Inverses mean opposite. But yeah, opposite. Well, there's one other piece. What do? What do we call? Reciprocal. An opposite and a reciprocal to get a 90-degree angle. So you got to know that perpendicular slopes, when you multiply their slopes, you're going to get a -1. The opposites, the fact that they're opposites gives you the negative, and the fact that they're reciprocals gives you the 1. Because everything would cancel out and you'll just have a 1. So what I wrote underneath is that they're opposite signs and reciprocal. They have to be both. If it's just opposites, that's not perpendicular. If they're just reciprocals, that's not perpendicular. It has to be both. So if you had these two, 2/3 and a -3/2, you would have perpendicular slopes. Because if you multiplied those two together, you would get a -1. If you took the 2/3 and multiplied it by -3/2, these 2's would cancel, these 3's would cancel. A positive times a negative would give you the -1. What about -3? What would I multiply that by to get -1? Okay, this is already a negative, so what do we need here? Positive. And we got to flip it, so it's going to be what? 1/3. Positive 1/3 is right. That would give, those two slopes would be perpendicular to each other. They would have 90-degree angles. Opposites and reciprocal slopes would give you 90-degree angles. So those are perpendicular, and these are also perpendicular over here. Okay, this will show you what I mean. Okay, we've got y equals 2x minus 1, that same blue line, right, that we had before. Now this time the yellow line's going this direction. Oops. And they put -0.5, so I put above it, I put -0.5. Just so you can see that that's really what that is, and is that the opposite and the reciprocal of 2? You change the sign, you'll get a negative. If you flip it over, you'll get a half, right? So these are perpendicular. You could actually take your pencil and put a box in there, because those are right angles. We know that they are because they have perpendicular slopes. So the slope of the first line was 2. The slope of the second line was -0.5, which we can change to -0.5. -0.5 is the same as -0.5. When you multiply those two slopes together, 2 times -0.5 or 2 times -0.5, either one, you're going to get -1. So multiplying their slopes gives you a -1. So 2 times a -0.5 or 2 times a -0.5, you get -1. So that tells us that, yes, for sure, they are perpendicular. Those two slopes are opposites and reciprocals, therefore the two lines will for sure make 90-degree angles. Now you notice that 90-degree angles don't have to be always straight up and down and straight across. You could turn them anytime you want. It's just as long as the angle itself makes 90 degrees, they're perpendicular. Okay, here's an example. Find an equation of a line that is perpendicular to the blue one, y equals -4x plus 10, and it's going to go through this point. So we need to find the equation of the yellow line. Find the equation of our yellow line here. So let's see what we do first. We need to find what the slope of your line is. The line that you have has a slope of -4. So that's your first step. Find the slope of the one that they gave you. So here the slope is a -4 because it's -4x. So whatever is next to x would be your slope, -4. Now you got to find the negative reciprocal of that one so that you can tell what your new slope is going to be. So what do you think? If it's -4, what's my new slope have to be? A positive and a 1/4, right? So we're going to need a positive 1/4 for the new slope. So you put the negative, you flip it around, and double negative, of course, makes a positive, so it's a positive 1/4. So your new slope of your yellow line has to be 1/4. Now we just need to see where this is going to cross the y-axis. It's probably going to be a fraction because it doesn't look like it's crossing at any of our lines here. We're probably going to have a fraction, but let's check it out. Let's see where it actually crosses by plugging it in. Again, we're going to use the same formula. Remember the point slope formula that we used last time? You can plug in a point and you can plug in a slope and you can get the equation. So I wrote the slope here with 1/4. It's our new slope. And we need to plug in x and y. So let's do that. We're going to plug in the 0.72. And when we plug it in, it'll look like this. Y minus 2 equals 1/4 times x minus 7. 7 was your x value and 2 was your y value. You plug in the 7 for your x, you plug in the 2 for your y value. And so far we're doing good. We just want to get y by itself. Again, we want to put this in slope-intercept form, y equals mx plus b. So we're really actually pretty close. You do need to distribute the 1/4, so it will leave us a fraction. So you're going to get y minus 2 equals 1/4 x minus 7/4. One-fourth times 7/1 would be 7/4. So now the tricky part is to add 2 to both sides. But I want to change 2 into a fraction that has a common denominator. What fraction that equals 2 has the same denominator as a 4? 2 times 4 is 8. So I'm going to use 8/4. Is 8/4 the same as 2? Yeah, so I'm going to get rid of the 2 and I'm going to use 8/4. So I'm going to combine. These cancel out. I'm going to get 1/4 x. And then what's negative 7/4 plus positive 8/4? Positive 1/4. So positive 1/4 there. So if you look at our little box, that's what we should have. They put x over 4. I would put 1/4 just so I can see my slope. So x over 4 plus 1/4, we got the right y-intercept. So 1/4 x means that our new slope is a 1/4 slope, and it's going to touch at positive 1/4. We knew it was going to be a fraction. It was just above the origin, and it was below the 1, so we knew it had to be some fraction that was pretty small. So 1/4 is what it came out to be. Okay, vertical lines, just so you know about the slopes of vertical lines and kind of horizontal lines. The vertical lines, thus the gradient or the slope is undefined because you can't divide by a 0. So if you were to look at these 2 points right here that they gave you on the picture, and you were to plug that into my slope formula, your slope formula is your y minus y over your x minus x. Y's over x's, rise over run. If you were to subtract 4 minus 1 and get a 3, 2 minus 2 and get a 0, you can't divide by 0. So vertical lines have no slope to it. You can't say it's got a slope of 1 or 3 or 10 or whatever. It's got no slope. You cannot walk up a vertical line. Therefore, there is no slope to it. Okay, that's what no slope is. Now, what about a flat line that's completely horizontal? That does have a slope. That's going to be a 0 on top and a number on the bottom. You can have a 0 on top. 0 divided by anything is 0. So the flat line has no slope, has 0 slope. So you got a 0 slope and you got a no slope. Those would be the two that we know there. So a vertical line is parallel to another vertical line, and a vertical line is perpendicular to a horizontal line. Vice versa. That's just little side notes. Vertical lines are parallel to another vertical line, so they would have two no slopes would be parallel. They both have no slope, that's still the same slope. So that's parallel to each other. And it's perpendicular to a horizontal, which means an x and y axis are always perpendicular to each other. Okay, just 3 left little examples, just to see if you can figure them out. There's just a couple of pictures, I think you see them on there. So let's see if we can figure out of these three lines, how would I prove which ones are parallel? What would I have to do to prove that the two of them are parallel? I'd have to find their slope. Okay, so let's do that. Okay, let's take K1 first. Okay, so K number 1. And we're going to put the formula, y minus y over x minus x. That's my slope. Okay, that's how you get m, so I'll put an m next to it. Okay, so this point right here is the point 0, 1, 2, 3, 4, 5, 6. This point right over here is the point 2, 0. So let's plug in those numbers and see the slope. So y minus y, 6 minus 0 on top. And on the bottom, you're going to get 0 minus 2. So you're going to get a 6 over a negative 2. You have a negative 3 slope. That's for K1. K1 has a negative 3 slope. Okay, over here, let's put K2. Okay, K2, let's go. We go over negative 1, negative 2, 1, 2, 3, 4, 5, 6. So this is negative 2, 6. This point is the point 0, 1. So let's plug in our formula. 6 minus 1 and negative 2 minus 0. So what's my slope here? 5 over negative 2. Is that the same slope as negative 3? No, this is like negative 2.5 right here. So definitely not parallel. K1 and K2 are not parallel. They kind of look almost parallel, but if you notice, they're getting a little closer as it gets to the bottom. So they would eventually touch, way down lower, but they would eventually touch. So let's try K3 over here. Okay, let's see. We've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So this is negative 6, 5. And this point down here is 1, 2, 3, 4. So it's going to be negative 4, 0. All right, let's go ahead and do y minus 5 minus 0 on top. That's the y minus the y. And negative 6 minus negative 4 on the bottom. Double negatives are going to become pluses. So we're going to get a 5 on top. Negative 6 plus 4 would give me a negative 2 on the bottom. Did we just prove two of them parallel? Yes, K2 and K3 have the same exact slope. So those are my two parallel lines right here. K2 and K3. If you follow those two down your picture, those are never going to get closer to each other. Those will stay the same distance apart the whole way. So that's proving that lines are parallel by showing that they have the same slopes. Which lines are perpendicular, or are they perpendicular? Let's just do a quick slope and see if they're opposite reciprocals or not. So we're going to take the red line, 2 minus negative 4 on top. That would be my y minus my y. And then on the bottom, it's going to be 4 minus 1. That would be my x minus x. They usually say y2 minus y1, x2 minus x1. You just have to stay consistent. So here you're going to add, you get a 6 over 3, which is a slope of 2. Let's try the blue line. So y minus y would be 2 minus negative 1. X minus x would be negative 1 minus 5. These are going to be pluses. You're going to end up with a positive 3 over a negative 6, which is a negative 1/2. Are those perpendicular? Yes. Okay, they are perpendicular. They do have opposites and reciprocals for their slopes. So they definitely have to be perpendicular. That's a yes. 2 and negative 1/2 are definitely perpendicular slopes. And the last one, it says, are these lines perpendicular? Let's get y by itself. Subtract 4x. So you cancel that out, you get 5y equals negative 4x plus 2. Divide by 5, you get y equals negative 4/5 x plus 2/5. Let's get y by itself over here. Let's subtract 5x. So you're going to get 4y equals negative 5x plus 3. You're going to divide by 4 on both sides. So you get negative 5/4 x plus 3/4. Are they perpendicular? They're reciprocals. Oh, they're not opposites. So that's definitely no. Not opposite. That's definitely a no. Equation of a line parallel and perpendicular to those lines that goes through this point right here. You're going to need to find your slope of this one first. So negative 3x, so you get negative 2y equals negative 3x plus 6, and divide by negative 2. So y equals 3/2 x minus 3. So that would be our original equation. We want to find a parallel line, so we're going to use the same slope. So parallel would be y equals 3/2 x and then plus b. We don't know what b is yet. So we could use our point slope formula, or we could plug in x and y here and solve for b as well. So if I put in the 4 equals 3/2 times negative 2, we could cancel those pretty quick and get 4 equals negative 3 plus b, and you're going to get b is 7. Okay, so if I plug this in, you get y equals 3/2 x plus 7. That would be parallel. That would be our parallel line. Perpendicular, you need the opposite and the reciprocal. So negative 2/3 x plus b, plug in the same point. So 4 equals negative 2/3 times negative 2 plus b. Move this up a little bit. So 4 equals positive 4/3 plus b. Subtract 4/3. This is going to be 12/3. You're going to get b equals 8/3. So negative 2/3 x plus 8/3. All right.